Good evening everyone. Myself Pawan Kumar, BTech first year first semester, Easy B section in Srinivas Ramanjan Institute of Technology. Video presented by T. Pawan Kumar. Topic name Constitution and Working Principle of PMMC. Introduction of PMMC. PMMC standard of permanent magnetic moving coil instrument. It is used to measure directly current DC and DC voltage accurately. It works on the principle that a current carrying conductor in a magnetic field experiences a force. PMMC instruments are known as for their high accuracy and uniform scale. Those instruments have low power consumption due to light moving points. PMMC is widely used as DC ammeter and DC voltmeter and galvanometer. Definition of PMMC: permanent magnetic moving coil instrument. It is an electrical measuring device used to measure directly current quantities with high precision. It operates by converting electrical energy into mechanical energy, which causes the movement of a pointer over a calibrated scale. A strong permanent magnet and a light moving coil are the main elements that then produces the required deflecting torque. The deflection of coil is directly proportional to the magnitude to the current flowing through it. A control spring system provides the restoring torque, ensuring steady and accurately reading. Due to high sensitive and accurately and linear scale, PMMC is widely used as a DC ammeter, voltmeter, and galvanometer. Principle of PMMC. PMMC works on the basic motor principle, which says that whenever an electrical current flows through a conductor placed inside a magnetic field, that conductor experiences mechanical force and starts to move. In a PMMC instrument, the moving coil is placed between the poles of a strong permanent magnet so that the magnetic field around the coil is uniform and steady. When direct conductor DC flows through the coil, it produces its own magnetic field, which interacts with the magnetic field of the permanent magnet. Due to the interaction between two magnetic fields, a force acts on the sides of the coil and produces a turning effect called deflection of torque, which rotates the coil. As the current increases, the force and rotation of the coil, also known as pointer attached to the coil, moves more, giving a larger and clearly readable. Main parts of the PMMC: permanent magnet produces strong and uniform magnetic field in which the coil moves. Moving coil: a light rectangular coil wall with fine copper wire that carries the current to be measured. A soft iron core placed inside the coil to strengthen a magnetic field to make an uniform. Control spring provide restoring torque to bring pointer back to zero and also carrying connector to and form the coil. Pointer scale: the pointer scale is attached to the coil and moves over a calibrated scale to show measured over damping system. Uses eddy currents to reduce oscillation and making pointer settle quickly. Construction of PMMC: current flow: when DC current flows through the moving coil, it moves magnetic field. Magnetic interaction: the magnetic field of the coil interacts with the magnetic field of the permanent magnet. Deflecting torque produces due to interaction. A force acts on the coil, latent force, producing a deflecting torque that rotates the coil. Controlled by spring: as the coil rotates, the control spring provides an opposing control torque. The coil stops, the both torques become equal. Working of PMMC: when a DC electrical current is supplied to the PMMC instrument, the coil flows through the fine copper and wire moving coil placed between the poles of a strong permanent magnet. Due to the flow of current, the moving coil produces its own magnetic field, which interacts the magnetic field already produced by the magnetic field. Magnetic field because of the interaction between those two magnetic field, a mechanical force acts on the coil which provides a turning effect called deflection torque that makes the coil rotate. As the coil starts to rotating, the control spring attached to the coil opposes the motion and provide control torque, and finally coil stops When both torque became equal, the pointer attached to the rotating coil moves over the calibrate scale and amount of and deflection by the pointer gives the current value on the DC current or torque of PMMC. When DC current flows through the moving coil placed in the magnetic field of a permanent magnet, a mechanical force acts on the coil produces turning effect known as deflating torque, which is responsible for the pointer. Deflating torque is directly proportional to the current flowing through the coil and mathematically given by TD is equal to B into N into I, which results in a uniform scale. As the coil starts rotating due to the deflating torque, the control spring attached to the spindle opposes this is motion and produces control torque, which increases the deflection of torque balance and deflating torque. Thank you, Ananda.